Alright, so I was asked why a quadrilateral inscribed in a circle, why the opposite angles are supplementary. So I told her I would explain, but I feel the need to start with this explanation first. So we talked about an inscribed angle being half the measure of the arc. So we talked about how this angle B right here is half of the measure of this arc. So let's explain first why that works. So first thing I did was I added this red line. Hopefully it shows up as red. And now I have a central angle. And so now I know the measure of arc AC, the measure of this arc right here, is equal to the measure of angle AXC, because this is a central angle. That point X is the center of the circle. Now, remember about first semester, we talked about exterior angles and remote interior angles. That the exterior angle, the angle outside of the circle, is equal to the two remote interior angles added up. So that's all I did here. So the measure of angle AXC, this angle right here, is equal to the measure of angle ABX, this angle, and BAX, this angle. So the exterior angle is equal to the two remote interior angles added up. Now all I'm saying is that XA must be congruent to XB. Well, how do I know that? Well, because they're both the radius of the circle. And so if these two sides are the same, if XA and XB are the same, well then these two sides are the same. By definition, that's an isosceles triangle. And if it's an isosceles triangle, well then these two angles have to be the same. Okay, so now, if ABX is equal to BAX, and we just set up here that AXC is equal to ABX plus BAX, but now we just said that these two are the same, well then the measure of angle AXC must be equal to 2 times ABX, and then we set up here that these were the same. So now I can just say that the measure of arc AC is equal to 2 times the measure of ABX. And ABX is up here, and so ABX is the same as ABC. So then I can say that half the measure of arc AC is equal to the measure of angle ABC. Okay, so we just proved the inscribed angles. Now, how does that affect us with the quadrilateral? Okay, so there's my quadrilateral. Hopefully you can see that I've got a blue and some red. So let's look at angle A. So angle A I have in red. And the arc that it opens up to is this arc BCD. And again, we just showed that if I know this angle, I can multiply that by 2 and it gives me the measure of the arc. So that's all I've done here. 2 times the measure of angle A is equal to the measure of arc BCD. And then I did it again on the other side. So then angle C, this blue angle, if I multiply this angle by 2, it must equal the measure of this arc. So that's all I've done right there. Well then, if I add up the two arcs, shouldn't they be equal to 360 degrees? Because they do travel all the way around the circle. Then I substituted in, because I just said here that 2 times A is equal to BCD. So instead of putting BCD, I put 2 times A. And then I said up here that DAB equals 2 times C, so I substituted those two. So now I'm saying that 2 times the measure of angle A plus 2 times the measure of angle C is equal to 360 degrees. I factored out a 2, so now I have 2 times measure of angle A plus the measure of angle C is equal to 360. Divide both sides by 2, and I get that the measure of angle A plus the measure of angle C is equal to 180 degrees. So I can do the same thing with angle B and angle D. And so we've just shown that if I have a quadrilateral inscribed circle, my opposite angles are supplementary.